Welcome to EXO Fleet's Insights, where every mile counts. The podcast where fleet data turns into real-world decisions. Each episode, we unpack what's really happening across mixed fleets, fuels and sites, and how better insights leads to better performance, lower costs, and fewer surprises on the road. So let's get into it. In our latest podcast on connecting the data for successful EV transition, we get an industry insight view from our COO, Alan Crowley. The saying, "you don't know what you don't know," has never been truer than when considering the road transport sector's transition to commercial electric fleets. Logistics businesses have big decisions to make, but currently there is a lack of institutional knowledge and independent support that is hindering the ability to make the first steps into this unknown. Only by gaining a complete picture from a fleet, facilities, service delivery and financial perspective will operators have the insight needed to achieve a successful rollout and meet the required performance metrics. As such, there will be a growing realization that vehicles, charging infrastructure, schedules, power supply cannot be managed independently in isolation. Everything has a consequence within a commercial EV operation, so it's about connecting these different aspects of a fleet together to gain a degree of confidence that you can get the job done. Operating commercial EVs is not the same as petrol and diesel powered vehicles, and never will be. This problem is that side by side the vehicles look the same, but they are not. It is a very different proposition. Much of what is currently known about running a commercial vehicle fleet will become less relevant with EVs, or at least be superseded by our operational considerations. This means an alternative approach is needed and operators will have to adapt to make this switch work. A critical part of the journey will be the adoption of smart tools to ensure essential fleet businesses achieve the day-to-day vehicle performance needed for financial and operational viability. The greater upfront costs of commercial EVs, alongside the expense of installing and maintaining on-site charging and power equipment, is well documented. But commercial vehicle operators also need to consider the financial impact of higher vehicle replacement ratios. The initial priority is to use available data to achieve a 1-to-1 replacement ratio, to minimise capital expenditure, and then to pinpoint where efficiencies and cost-saving opportunities exist. It is crucial to look at transitional and operational planning together to develop an electric vehicle fleet that is fit for purpose from day one, while information can be fed back into the system to fine-tune processes and target continuous improvements. This added intelligence also becomes very useful for specifying and implementing the next rollout vehicles and infrastructure. Up until now, early adopters of commercial EVs have been looking at the vehicle and charger in isolation, while attempting to coordinate the schedule in the same way as before. This is a recipe for failure because it is important to understand the main parameters that contribute to the successful operation of an EV and how they influence each other. Understanding the interdependencies between different systems will help to identify trends within a commercial EV operation. When charging should occur? When is the most efficient time to charge? What is the best type of vehicle to use? What is the impact of different routes, load impacts, or driving conditions? Moving forward, AI will enable vast amounts of data to be analysed and acted upon faster and more efficiently than ever before. Vehicles' charging stations, schedules, supply equipment, maintenance systems all generate huge volumes of data, which can be integrated and analysed to generate valuable insights. When you are collecting information from thousands of data points on an hourly basis, manual analysis is simply not feasible. But with AI, there is a huge potential to streamline the automated operational processes. Right-size commercial EV fleet infrastructure. Commercial fleets risk increasing capital expenditure by up to a third when transitioning to zero-emission road transport by oversizing their electric vehicles infrastructure. Currently, there is a fear factor especially around the vehicle range and charging availability, which is impairing effective decision-making around battery levels and fueling redundancy. Electrification is a complete shift in the paradigm of fueling. A fleet is going from getting 100% of the vehicle's potential range in a matter of minutes with diesel, a very reliable and widely understood system, to rely on the new technology that requires hours of charging to provide a similar range. Coupled with this, the battery of an EV certainly has more range, sensitivity and variables that impact fuel efficiency from day to day. So the concerns with the marketplace are totally understandable. For any commercial fleet manager, it is critical that they have the vehicles needed to complete their daily operational requirements, so highly reliable and uptime is key. To mitigate the range anxiety in particular, we are seeing examples of commercial fleets investing in 20 to 30% more batteries than are needed. This in turn leads to a larger charging infrastructure and additionally electrical service, which drives up the costs significantly. There are many pitfalls and common mistakes associated with fleet electrification that will impact the ability to manage electric vehicles, cost efficiency, and meet operational needs. As such, commercial fleets need to look at the data from the existing vehicle operation to determine what configuration is required. This data approach looks at the vehicle spec and battery size alongside service requirements, range sensitivities, and the time available to charge, so any design solution delivers a cost-effective, just-in-time rather than just-in-case program. Energy management is another major consideration, as some costs often get overlooked in the planning stage when calculating total cost of ownership. Local grid operators can be complicated. Rate structures resulting in significant premium at certain times of the day, so you need a system that eliminates or vastly reduces charging during these periods to minimize expense on the fueling side. In many cases, fleets are also charged for having dedicated capacity available on the top of paying for the actual consumption of that energy, which means there is a huge financial incentive for right-sizing the charging infrastructure from the start. When buying equipment, it is crucial for industry standard protocols to be supported. Frameworks such as Open Charge Protocol (OCPP) provide third-party hardware and software with the ability to communicate together in a meaningful, robust and reliable way. This will ensure that the commercial fleet has the right system and processes in place to effectively manage the operation, charging and energy, while understanding where inefficiencies exist to target continuous improvements and support future planning. Commercial electric vehicle adoption will continue to gather pace as new types of models across vans, HGVs, specialist vehicles become available. This rapidly changing landscape is being driven by ambitious legislative roadmap for decarbonising. EVs, if managed correctly, can be the less expensive option for commercial fleet operators. The transition will be a major change for any organisation, and there are significant risks and challenges to face, but not insurmountable, especially through the use of smart tools and integrated data. Make sure to keep the conversation going and reach out to ZeroMission's Alan Crowley today. If anything you heard today reflects the challenges you're facing in your fleet, get in touch with us today at Exofleets. We're always happy to talk through real-world solutions. exofleets.com